Good morning, guys. Today we're going to expand on what we worked with in the last section, which was designing a sample. How do we get individuals to gather information about? Today what we're going to do is we're going to focus on how do we design experiments. How do we actually gather information from those individuals? We looked at it through surveying a little bit. Now let's see if we can talk about observational studies, which is similar to surveys, and experiments, which are very different from those surveys and from those observational studies. So I got two different studies here I want to kind of describe and talk through. Study one, do the ACT scores of seniors significantly improve on the fall retake? And so what we would do is we compare spring ACT scores to fall retake scores. So if we're just looking at these right here, we're not doing anything, right? We're not making any kind of changes to individuals. We're just observing what they did in the spring and comparing that to what they did in the fall. So when we have an observational study, what we're talking about is we're going to observe the outcomes of an interaction between explanatory and response variables. So we're just observing what occurs. So in this case, the explanatory variable will be when you take the test. So the timing of the test, what season you take the test. And then the response variable would be what you scored on, what those individuals scored on the test. So we're just observing what happened between them. Okay? So I like to think of an observational study as like going to a museum. It's look, but don't touch. Look, but don't touch. You're just watching what happens as things kind of naturally occur. That's not to say that I can't tell somebody to do something, because I may need to tell them to do something so that I can observe what happens. So for example, if I wanted to just observe a person's heart rate while they're jogging, I may need to tell them to jog. You know what I'm saying? So that could still be an observational study. I'm not making any changes to them. I'm just telling them to go jog, and then I can observe people of one trait who jog versus people of another trait or another characteristic who jog. So I'm just observing, again, what's going on. I'm not changing that trait about the individual, but I am going to tell them to go jog and initiate what we're looking at. So we can still have a little bit of touching, but for the most part, it's about not making changes to the individuals. Now, the limitation on observational studies is because we're not making those changes to the individuals, there's this potential for confounding. What is confounding? Okay. So confounding is this idea, let's say, if I was to say that there is a scenario where, as a common example, as ice cream sales go up, shark attacks go up. Right, so we could look at the graph of how much ice cream is being sold and how many shark attacks there are, and we can see that both of them have that there's a positive association between the two of them. Now, we reasonably understand that people selling more ice cream or buying more ice cream is not causing people to be attacked by sharks more often. So there are other possible explanations as to why both of those would be going up or increasing at the same time. That's what we're talking about with confounding. Okay? Confounding is when another variable influences both the explanatory and response variables. And what that does is that makes an appearance. So making the appearance of an association. When those two aren't actually related, there's no play going on between them, they just happen to both be tied to the same variable. So they both have to be tied to the same variable. So in the shark attack ice cream example, temperature is really the confounding variable. As temperature goes up, more people are going to buy more ice cream, and more people are going to be out in the ocean more and going to be interacting with sharks more often. So I like to think of confounding as just other potential explanations. Other potential explanations. That's what confounding variables are. What are these other things that could be causing this stuff to go on? And maybe it's actually causing both of these variables to change the way they are. So with observational studies, because we're not making any changes to the individuals, we're not putting any controls on it, there's always this potential for confounding variables. So it limits the conclusions we can really draw. So we can see an association. We're going to talk about this more in the next section. We'll talk scope of inference, what type of conclusions, but really because we don't know what all these other potential explanations are, we didn't really put any checks on them. We really don't know if one of them was causing the difference or the actual explanatory variable is causing the difference. So we can find an association, but not necessarily a causation. Now, in study 2 here, we get a little bit more hands-on with what we're doing. All right, so in this second one, does ACT boot camp significantly improve scores on the fall ACT retake? So this is one that we could put some hands on it, okay? So I could make some students take ACT boot camp. We're gonna look at 2 little scenarios later. I can make some students take ACT boot camp and then other students not take ACT boot camp, and I can then compare those 2 groups' scores together. Now I'm getting involved on that characteristic, that trait that's between them. So this is an experiment. So in an experiment, whoever is directing the study is going to impose changes or differences on the individuals in the study. Right. So we're going to impose changes or differences on the individuals in the study and measure the effect. Okay? So we want to measure the effect or the response to those changes. Measure the response to those changes. So I like to think if observational study is look but don't touch, an experiment is touch everything. I want to get very, very hands-on with an experiment because I don't want these other potential explanations to be happening, these confounding variables. So I'm going to get hands-on with what I do to try to control those things or eliminate them as possible outcomes and really get into where we say, okay, this variable that I'm concerned with, that I'm focused on, is really what's causing the change in this or not causing it changes, depending on your result. All right, so that's what we mean when we talk about an experiment. So a couple of vocab words with experiment. First one is treatments. So this is kind of a word I think that you guys are pretty familiar with. Treatments, people think like medicines and stuff like that. Well, a medicine is the type of treatment because it's a change that we're doing, right? Something that we're imposing on you. So treatments are just the changes or differences that we impose. So what did I tell one group to do but not another group to do? Okay, so for example, in this one, the treatment that we would be working with is the ACT boot camp. We would tell some students to do ACT boot camp, and we would tell other students to not do ACT boot camp. That's the treatment. We're making that change. We're making that difference between our 2 groups. Okay? Next, we have experimental units. So experimental units, I've already kind of used a word for that. That's just individuals. Okay? Experimental units are the individuals all right, so the individuals that we are experimenting on. Well, I'm going to say experimenting with. All that sounds kind of mean. Experiment on things. Now, speaking of, another word that we will use for experimental units, sometimes we'll call them subjects. especially when you're dealing with people or animals, living things. People don't like to be referred to as experimental units very often, so you may call them the subjects of the experiment. So this is the big differences between whether it's an observational study or an experiment. Am I just looking at what's naturally occurring, or am I actually imposing changes? I'm making a change to someone's behavior or what they wear or what they do, and then I'm measuring the outcome of those. Now, let's look at how we design a study, because for something to be an experiment, we need a lot of certain things that we do if it needs to be a well-designed experiment. There are a lot of things that we want to put in place to make sure we get a good measure of that effect. So let's look at the 4 principles of a well-designed experiment. So as we see, there's a whole lot of stuff going on here, but the big things are the 4 principles of a well-designed experiment. There are the 4 things that we really want to hit on if we're saying this experiment is going to give us good results. It's going to give us information that we can draw good conclusions from. So these are the 4 things we want to hit on: comparison, control, replication, and randomization. Those are the 4 principles of a well-designed experiment. All right, so what do we mean when we say comparison? Well, obviously you want to be comparing things. So I would never just look at one thing, one treatment versus nothing else if I'm going to do an experiment. I need to be comparing one group, one change to another change, or another difference. So what a comparison does, a comparison allows us to measure the difference. And that's what we care about. All right, so it allows us to measure the differences that result from treatments. The differences that result from treatment. And the treatments are really just your response variable. And so it's the values of your response variable. So in this case, our treatments, like we were just talking about, would be boot camp and no boot camp. So I wouldn't just put everybody in a boot camp, right? Because then that wouldn't give me a comparison. I would need some people in a boot camp, some people not in a boot camp, so I have 2 treatments there. Okay, so 2 values of the response variable, and that way I can get a comparison. I can measure the difference in those results. Right, next we have control. Well, what is control? Control is how we try to take care of all of those confounding variables and things, or one way we try to take care of some of those confounding variables. All right, so we want to limit confounding variables So control is just limiting confounding variables. And why do we want to do that? Because we want to isolate the explanatory variable. So our explanatory variable, that's just sort of thing, guys. Treatments are going to be our explanatory variable. The values of the treatment are the explanatory variable. Those differences, the measured differences, that's going to be our response. So this would be our ACT scores, the difference in ACT scores. This would be whether or not we're boot camp or non-boot camp. So what we're wanting to do is we want to isolate the explanatory variable. We don't want anything other than ACT boot camp to be the explanation of why there is or is not a difference in those ACT scores. So that's what we do with controls. We want to limit confounding variables to isolate the explanatory variable. So we're going to try to think of all the other possible explanations, possible things that could affect ACT score, and then we want to try to put some controls in place. We have different ways we can kind of go about those. But controls are just, some of it's through our randomization, through our grouping. Maybe we pick everybody that's in a similar group. We only test people with certain characteristics, certain traits. So if you thought gender played a role. Maybe we only look at guys and how they react, or only look at females and how they react. If you thought that race played a role in ACT scores, or socioeconomic status plays a role in ACT scores, or I don't know whether or not you had breakfast plays a role in ACT scores. Maybe we make sure everybody has breakfast before they come in. So all these other things that could explain why somebody scores a certain thing on the ACT, we want to try to control. Right? So when I think of control, I think of make as much the same as possible. I want to get as much stuff the same between my group that had ACT boot camp and group that did not have ACT boot camp, to where I've isolated the explanatory variable. I want to look at these two groups, and if I didn't see a boot camp, I would think they're all the exact same group. Okay? But I want the only differences between the two groups to be ACT boot camp. Now, we know that's not possible to get everything the same, everything identical. Again, we have some tools, especially with some of our randomization techniques, but we can try to get as many things as possible because we want to eliminate those other possible explanations. We want to limit those confounding variables. Hard to eliminate all confounding, but we can limit and minimize it. All right, so one way that we can get controls is to use a control group. Now, a control group is just a group that we don't do anything with. Okay, so it's the no treatment group. The no treatment group. That group, if you were going to do nothing at all, this is what you would get. So for us, that would be like our no ACT bootcamp group. So they're like your control group. This is the what's everybody doing that's not participating in bootcamp, and then our bootcamp group. So this gives you baseline results. If we did nothing at all, where would we be? Okay, so it's often good to do a control group. You don't always have to have a control group, but it's often good to do a control group because sometimes you want to kind of test whether or not it's even worth doing anything. Maybe you can find an effect of something, but the effect from doing something to doing nothing was so small that it wasn't worth the investment that you had to put into it. So maybe the ACT group bootcamp does better, but it's not a high enough difference or large enough difference that it's worth the money and the time that you have to put into the ACT bootcamp and organizing and all that kind of stuff. So that's what we're talking about the control group. You don't have to have a control group in every study, but a lot of times it's good to just have those baseline results. What if we did nothing at all? All right, so there's the two C's, comparison and control. Now let's talk about the two R's, replication and randomization. So replication, well, I think it's pretty straightforward. Like replicate, you want to do it again and again and again. Now, it doesn't necessarily mean we need to do the study again and again and again. Okay, you want to design it so that other people can go and replicate your study and see if they can replicate similar results, because that gives you more validity to your results. But really, for what we're talking about with replication, we just want to make sure you have enough data points to compare. Make sure you have enough data points to compare. So I don't want to compare one person that took the ACT bootcamp to one person that didn't take the ACT bootcamp. Because while I may see a higher score in one versus the other, there's a whole lot of other confounding variables, right, going on. So I want to be able to look at large groups. So for us, replication just means that we have a large sample size. Large sample size. Now, how large is large enough? That's something we're going to talk about in future lessons when we talk about inferential statistics as far as trying to meet conditions for certain hypothesis tests and things like that. So large is relative at the moment, but we just want to see it right now is, do we have a lot of data points that we're able to compare? So that's what replication means. Randomization. Randomization, well, that's kind of the big deal right here with an experiment. This is truly what helps us to get to an experiment. So we're putting controls, we're making sure we're comparing things, we have large data sets, but if we don't have randomization, it was all for nothing because we haven't really put those confounding variables in check. So for us to have a well-designed experiment, I mean, you could have an experiment without randomization, but it doesn't really tell you anything. Not really anything useful and conclusive as far as a cause and effect relationship. So randomization says you must randomly assign treatments. So must randomly assign individuals to treatment groups. If you don't put them into treatment groups randomly, then you have all these other variables, confounding variables that could still be going. So just like we talked about with randomly selecting individuals, we know that when we do randomization and selecting individuals, it scatters all of those characteristics across the sample. It's the same idea here. That's one of our biggest ways to control for confounding variables. If we will randomly assign people to which treatment they're going to get, it should take a lot of those potential confounding variables and scatter them amongst your treatment groups. So that's why randomization is so important. Now we have 3 different ways we can get to a randomization. There are more than this, but these are the 3 that we want to focus on. And again, you could do combinations of these. First one is completely randomized. Completely randomized is just like it said. Okay, completely randomized says any treatment group is possible. And any treatment group is possible. So what does that mean for any treatment group to be possible? It means all individuals come from the same hat. So I put every single person in my study in their name on a slip of paper, throw it in a hat, and pull them out. First person, your treatment 1. Second person, your treatment 2. Third random person, your treatment 4, and so on, right? Or we random number generate, or we spin the bottle, or we roll dice. Any of those sampling or randomization tools and techniques we talked about before. Everybody can be chosen. So one person being picked for treatment 1 does not affect any other person's chance of being chosen for treatment 1. So that's completely randomized. Now, just like with simple random samples, we run that risk of over-representing one characteristic or one trait in our sample. We run the risk of over-representing one characteristic or one trait in a treatment group with completely randomized. So then we have things like randomized block and matched pairs, which allow us to put some more controls on things. So these are forms of controls. They allow us to put a few more checks on these confounding variables. So randomized block is the first one. That's nothing more than grouping subjects by some potential confounding variable. So we're going to group subjects by a potential confounding variable. And then randomly assign treatments. Now, the groups, when we talk about grouping subjects, that is what's known as blocking. So we call it randomized block. So we're going to randomly assign treatments, not to each group, right? Because I don't want one group to get one treatment and one group to get there. I'm going to randomly assign treatments within each block. All right, so let's say that we thought a really big variable that we want to control for is gender. We know that females typically score higher on the ACT than males do. So we don't want to oversample or over-assign our females to either one of the treatment groups because we feel like that could throw off our results. So we want to control for gender. So what we may do is block by gender. Now, gender is not the variable that we're testing. We're testing ACT boot camp, but we want to control for gender to make sure we, again, don't over-represent gender, a specific gender in either one of our treatment groups. So the way we would do that is we would separate our group. So say we got 100 students that we're looking at taking the ACT in our little experiment here. So if we got 100 students and we want it to be 50-50, something like that, we could take our females. So maybe we had 60 females in our sample, and then our males, we had 40 males in our sample. So out of our 100 random students from Riverdale, 60 were female, 40 were male. And then we said, okay, we got to control for gender. So now let's separate. Let's work the males, work the females. So from there, what you've done, as soon as you block, you've now taken one experiment and turned it into 2 experiments. So now we're just saying, what's the effect of ACT boot camp on females, and what's the effect of ACT boot camp on males? So that's what we've gathered from blocking. So once I've done that, now I'm going to randomly split the females. So that I get 30 in boot camp, and then 30 in not boot camp. Same with the males. I get 20 in boot camp, and then 20 in not boot camp. Now here's kind of a limitation on randomized walk. Not a limitation, just something you have to consider. If I split these up into the treatments, I can't put them back together. I can't say, okay, now I have my 50 boot camp and my 50 non-boot camp. If I think that gender is a big enough deal to need to block by, to need to separate by, then I need to keep these separate. So I need to truly take my one experiment, turn it into an experiment for females and an experiment for males. So I'm looking at my results. I'm going to say, this is what we learned about females and how they respond to ACT boot camp. This is what we learned about males and how they respond, because we thought that was big enough to. Now, if I get to the end and I realize, okay, the males and females responded pretty much the same to ACT boot camp, then I can put all that information back together, because then that tells me, okay, gender didn't play a role in how they were going to score on the ACT. So we can go ahead and put that information back together. But for right now, when we're assigning our treatments and stuff, you want to keep that data separate until you see at the end that the 2 responses were the same. All right, so that's randomized block. It's a really, really good way to be able to compare or control for a big confounding variable, some big obvious thing. All right, next we have what we call matched pairs. Okay? And this is one I always write Paris for some reason. Maybe it's because those 2 numbers or those 2 letters swap. So just watch me in class, because I'll write matched pairs quite often. All right, so when we talk about matched pairs, maybe we acknowledge that there's a lot of things that play a role in how somebody's going to do on the ACT. So not just gender, not just ACT boot camp. So what if we acknowledge that gender may show up as gender may play a role. As we said before, socioeconomic status may play a role, because maybe your parents have more money to get you a tutor and stuff like that. Maybe extracurricular activities play a role. Maybe race plays a role. Maybe all these different little intricacies of those differences between individual people play a role, to where I can't make a bunch of individual block, because then you just end up comparing one person to one person, and we lose our large sample size. So when we deal with, one person to 149 or 99 other persons. So what matched pairs does is kind of let us take it on a person by person basis, or subject by subject, individual by individual basis. So when we say we are going to do a matched pair study, we're going to pair subjects with another subject right? So another subject who possesses similar characteristics. have similar characteristics that are relevant. So I guess I could say similar relevant characteristics. So that might be, I might take a black female who's plays sports and her parents, make like $110,000 a year, something like that. And I'm gonna find another black female who plays sports and her parents make around $110,000. So I'm gonna take these two students that, for all these traits that I think might play a role in ACT, these two students are nearly identical. If I just looked at them on a piece of paper and all their boxes that you would check on them, they look nearly identical. I can pair those two students together. Okay, so by pairing them, I am controlling for all of those confounding variables. I'm making as much the same as I can between those two students. From there, once I have these two identical students, then I can randomly assign. So once you've paired the subjects up with another person possesses similar characteristics, then we can randomly assign the treatments within each pair. So I can pick one girl and I can just flip a coin and be like, okay, if it lands on heads, you're going to ACT boot camp. If it lands on tails, you're going to ACT boot camp. So we can just randomly assign. Then I find my next two students and I try to get them as identical as possible, and I'll flip a coin on them, ACT boot camp or not. And then I'll bring my next two students, and I just keep going all the way down until I've paired everybody up as close as I can to another student, and then we've randomly assigned within each of those pairs. So that's what I mean by matched pairs. Now, pair, in this case, it's pairs because I only had two treatments, ACT boot camp and then the control, no boot camp. So pair is kind of a relative word right there. If I had three treatments, I could do matched triples. I could find three individuals that were near identical. But that's the idea, is we want to try to group individuals or get them with similar characteristics and then randomly assign them to treatment groups. So we can put control in scattering all of those other explanatory variable or potential confounding variables amongst all of our treatment groups. That's one way that you can do a matched pair. There's actually a better way you can do a matched pairs study. So matched pairs, pairing them with somebody else that's similar to them is useful, but there's a better way to do it because you can pair an individual with somebody that's identical to them. And that would be pairing them with themselves. All right, well, what does it mean when we pair a subject with themselves? Well, if we think of a pair, we've got two individuals. We've got two individuals, and then you're going to randomly decide which one gets which treatment. Well, in this one, if I have one individual, and I'm randomly assigning them treatments, I'm really giving that person both treatments. So that's what a matched pair study is. It's when you have one person do all of the treatments and you compare the data points amongst that one person. Then I'll grab another person and give them all of the treatments. And then the third person, give them all the treatments. So then I can look at how everybody responded to the one treatment versus how everybody responded to the other treatment. I'm still getting my comparison. I'm still getting a large sample size. Okay? I'm now controlling for all of those confounding variables, potential confounding variables, those lurking variables, by saying, okay, all of your traits that would affect the ACT are the same whether you're in boot camp or not in boot camp, things like that. So I'm going to pair a subject with themselves, but we still have to have randomization, right? Just like all of these have. We put everybody in a hat. Even when we do this, we were going to randomly assign something. We're going to randomly assign what you get. So you still have to have randomization. So where the randomization occurs in a matched pairs scenario where you're paired with yourself, randomization is going to occur in the order that you do them. Maybe the order you take the treatments could affect how you respond to treatments. So you have to randomly determine the order. So we're going to randomly determine the order of the treatments. So you're still getting your randomization, even though we're not randomly deciding who gets the treatment, because everybody's going to get all the treatment. You're going to randomly decide the order. So in this scenario, we're talking about ACT boot camp. Would matched pairs really be a good idea where you pair with yourself? Probably not, because with some people getting ACT boot camp first, and then some people taking the ACT a second time without having taken ACT boot camp, those people that took the ACT boot camp the first time, they've now felt the effect of that. Like, that's a permanent change it makes to you because you've learned those skills. You've at least got to experience that. So this is a really, really good strategy. It's probably the best one you can go with, but it's only if the treatment does not permanently alter the individual. Doesn't alter them to the point that if they end up with it first, it affects every other possible treatment after that. So matched pairs, pairing with yourself is ideal, but not always reasonable, not always possible, for example, in the one we're working with. There are situations where I could do a matched pairs pair with myself if I was wanting to compare how I run with different types of shoes, something like that. That would be pretty good because I could do one type of run with one shoe and then come back in a couple of days and do another type of run with another type, or the same type of run with another shoe. So whichever shoe I use first, it's not going to change how I react to the other shoe, like taking ACT boot camp before the first test or before the second test. All right, so that's our 4 elements of experimental design. So just some other little odds and end words, vocab we need to take care of. First one we got is placebo. I think most people are familiar with placebo. So another way we can get a control, or our control group, the no treatment group, is to give them a placebo. So a placebo is when subjects think they are receiving a treatment but aren't. So they think they're getting the treatment, but they aren't. So they're the control group. Why do we do that? Because we want to see if maybe just the physical effect of taking a treatment of some sort. So maybe we had some type of subliminal messaging video that we were showing people. And some people got the video with the subliminal message in there. Some people just got a regular old video. So we want everybody doing the same things, but they wouldn't know which video they were seeing, so to speak. Now, placebo effect is an interesting phenomenon, and that's where placebo people with no treatment, actually start reacting as if they were receiving the treatment. So maybe they reacted like the people that saw the subliminal message video. So they were doing the same things, and they had no reason to do those things. All right, so placebo effect is when placebo patients that marker is dying on me. Let's go here. When placebo patients respond as if they're receiving the treatment. Example, that would be, I just kind of gave an example, but this could be, say, you're somebody that's highly allergic to like poison ivy or something, and somebody could rub a leaf on you that looks like a poison ivy leaf, but maybe it's hog peanut or something. Something that kind of looks similar, but is not actually poison ivy, and then your body could react, could swell up, could get some blisters in that area because your body is convinced, or your mind's convinced that you actually interacted with poison ivy, and it knows, okay, I need to, send out my defenses and make a blister there or something like that. So that's kind of an example of placebo effect. The individual reacts as if they got the treatment, but they weren't receiving the treatment. Then we have blind and double blind. These are actually 2 words that have kind of been thrown out a lot with all the efficacy of different COVID treatments that have been going on here lately. But a blind study just means the subject doesn't know which treatment they're getting. Okay? So they don't know, am I in the placebo group? Am I not in the placebo group? Subjects are unaware of which treatment. Why is that a benefit? Because maybe they, if they know which treatment they're getting, maybe they're going to behave differently. Maybe they're going to give a different type of response if you're doing interviews, things like that, because they know what's supposed to be expected. So it's good if people don't know which one they're participating in. And then the last one is double blind. It's an expansion of that. So double blind is just where nobody knows, right? So subjects and data collectors are unaware of treatments. So somebody in the study is keeping track of which person has which treatment, but the person that's receiving the treatment, and the person that's gathering the information, gathering the data, doesn't know which treatment a person has. Again, that's just to kind of help make sure there's not influences. Like, so if I was interviewing somebody and I've been committing 10 years to the research on this, and I know they've been getting the research, or they've been getting the treatment, maybe I'm going to ask them questions, not intentionally, but just kind of human nature. Maybe I emphasize a word a little bit differently just to try to, indirectly influence their response so I can get the results I need to justify the 10 years that I've spent on this particular research. So to kind of cut that out, we just have neutral people that don't know who's getting which treatments, just go gather information. Just send somebody that's not involved at all in there to draw blood or do an interview or whatever it happens to be. All right, now we talked here about trying to measure differences in the comparison. That's the last thing I want to mention up here, trying to measure these differences. These differences, we want them to be what we call statistically significant. So this is a phrase that we're going to use a lot going forward, but statistically significant doesn't necessarily just mean that there's a difference, okay? It means that it's a big enough difference. All right, so statistically significant means a large enough difference a large enough difference to conclude an association. Between the response and explanatory variables. So it just says that we got a big enough difference in ACT scores to say, yeah, ACT boot camp did have some type of effect. Big enough difference to conclude an association between the variables. So I could come back and say my ACT scores for my boot camp group, maybe they were on an average of 24.1, and my non-boot camp group, maybe they were an average of 22.3. So that's almost a 2-point difference. And we go through into our inferential statistics, and it says that's a large enough difference to say, yes, something occurred with the ACT boot camp group, and then we could decide whether or not we want to continue with it or that. Now, that's not to say it has to be a large difference. I could get a statistically significant difference of half a point or a tenth of a point, just depending on what my sample size is and all that kind of stuff. So the arithmetic can say something significant, but that doesn't mean it's meaningful. We'll talk about that much later in the course when we talk about inferential statistics, where things can be, there can be a difference there that says, yes, this caused that to happen, but is it a meaningful difference? Did we get enough out of it? I don't know. Coming back to that, was it even worth treating at all type scenario. All right, so these are our 4 elements of a well-designed experiment: comparison, control, replication, and randomization. And we know experiment is where we touch everything, get our hands all over it. Observational study, we look but don't touch. Tomorrow when we come to class, we'll put up a couple of different studies with this ACT boot camp, and we'll kind of compare these 4 elements and see how each one of those studies address the 4 elements of the well-designed experiment. But that's it, and I will see you in class tomorrow, guys.